So we were asked to show an application of calculus, and we thought, why not try something useful? So we found ourselves at the local watering hole. Like most students, we wanted to get the most out of our money, so we went with the $2 pint special. After all that, how can I be sure that I got a pint of beer out of that? You guessed it. We came prepared with our ruler, our toothpicks, and our calculus skills. So we got our empty glass, but we're going to need to know a couple things so we can do our calculations, like the height. And the radius. So we have our height and we got our radius. But what about the bottom radius? Got it covered. So I couldn't measure the bottom of the glass, so I used a toothpick and broke it to size.
Well, Larry had a little bit too much to drink, so we're going to have to switch over to our local math whiz who hasn't had quite as much to drink as
Okay, so all we really need to do here is to come up with a little XY coordinate system where the x-axis runs right through the center of the glass. Now we know this coordinate right here is at the height of the glass and is the large radius at the top of the glass. And we also know this point is at 0 and the small radius of the glass. Using that, we can figure out what the slope of this line is using the numbers from our measurements. Okay, so we've already figured out our slope, good old change in y over change in x, and what we end up with there is this decimal, 0.131 and some other stuff there. So we go with slope-intercept form to find an equation defining the line of the glass. Your slope times x plus your y-intercept, which just happens to be the lower radius here, 22 millimeters. Now if we want to find out the volume, all we need is the integral of the function squared times dx all times pi. So we take the integral from 0 to the height of the glass, meaning slices summed up from here all the way up, of the function squared, which plays out to this nasty mess down here. Okay, so we've got our integral set up here. And what it all works out to, and I had to use my calculator because it's a pretty messy integral, works out to the volume is equal to pi times 141,000 and change cubic millimeters. Well, it just so happens that a cubic millimeter is a microliter. So what you end up with is the volume is approximately 445 point something or other milliliters. A US pint is 473 milliliters, as you see here. So if you do the math and get the difference, you're looking at 28 mLs, not a whole lot, 28 thousandths of a liter. So yeah, we pretty much got our money's worth. And then when you consider this, our toothpick method was imperfect. You can see the broken end is well underneath the other toothpick. So there's a gap down there. Might not be 28 milliliters, but we were pretty close. Feel we got our money's worth. Now, we could go with all this math, of course, but there might be an easier way. Maybe we could just use a known amount. So I went ahead and poured a pint of water in here. Let's see if it fits. And if you look, the meniscus is over the top of the glass. Does not leave a lot of room for foam, so barely getting your money's worth here. And of course, for the safety of any given experiment, you've got to have a DD. Thanks a lot, Dave.